Hi, I'm Nick Raboy from MongoDB. In this tutorial, we're going to see how to create an autocomplete form on a web page that leverages MongoDB. So for example, let's say that we have text input on a web page. When the user enters some information into that field, we want to give them suggestions on what they're typing. So for example, if they type in cheesecake or if they type in cheese, we want to be able to show them, hey, cheesecake might be an option depending on what's in their database. So up on my screen, you'll notice that I do have the MongoDB Atlas dashboard open. In this particular example, we will be leveraging MongoDB Atlas. So what we want to do is we want to click on collections. We're going to assume that you've already created the proper user and network rules for your application. If not, go ahead and search the documentation for a getting started tutorial. Once we've opened up our collections, let's go ahead and create a new database. In this particular example, we're going to call it food. And for our collection, we're going to call it recipes. So we're going to have very basic recipe names and recipe ingredients. And we're going to be searching based on the names of the recipes in our database. So for example, let's go ahead and open up that new recipes collection, and let's go ahead and add a few documents. So I'm going to insert one document right now. This particular document is going to have a name field. In this case, the name might be grilled cheese. It's going to have an ingredients, and ingredients is going to be an array of string. So for example, one ingredient might be cheese. Another ingredient might be bread, and then maybe there's butter. Now, of course, the recipe might be more involved than what I have on the screen, but it's enough to get us started for this example. Let's go ahead and insert it. Now let's go ahead and insert another document. We're going to keep that trend of cheese-related recipes. Now, we could always revisit this in the future and add more recipes, but for now, this will work out. So let's go ahead and give it a name. The name in this case might be cheesecake. Now, cheesecake is going to have some ingredients as well. This, again, is going to be an array of string. And for one, we might have cheese. Another, we might have sugar. And we might have graham crackers. I'm going to insert it. Now to see the full power of autocomplete with MongoDB, you're probably going to want many more documents than I have listed in this particular example. However, this is just an example, so we're going to be working with just a few. So we have our two documents. Now what we want to do is we want to create an index on our collection so that way we can use autocomplete on it. So what we can do is we can say search indexes. And let's go ahead and create a new search index. Now for this search index, what we're going to have is we're going to have mappings, but we're going to set dynamic to false because we want to map a particular field within our collection. Let's go ahead and say fields. And we're going to have one field and we're going to call it name because that's the field that's within our document. And this name field is going to have various information about it. So for example, we have fold diacritics, and this is going to be false. We have max grams, which we're going to set to 7. We have min grams, which we're going to set to 3. We have tokenization, which we're going to set to edge grams. And we have type, which is going to be autocomplete. Now, if you have any questions regarding what each of these particular fields means, you can visit the MongoDB documentation for index definitions. You'll be able to scroll through and look for autocomplete and see what each of those properties means. So for example, when it comes to the tokenization method, we chose edgegram, but there's also ngram as well. Go ahead and read through the documentation and pick the settings that works the best for you. Let's go ahead and go back into MongoDB Atlas, and we're going to create that index. Now, it could take a moment or two to create that index depending on how much data exists in your MongoDB collection. So you can see that the build failed. So let's go ahead and figure out what we might have done wrong. So let's go ahead and look at the edit index, and we can very easily click on the error as well. But let's see what happened here. So on line 10, you'll notice that I chose to use edge grams. What we actually want is we want edge gram. So let's go ahead and apply the index changes again. Now the point of that was to show you that, you know what, your index creation could fail, and that's a good thing because you want to make sure that it was created properly. So our index was created successfully this time. Now that we have our data, we have an index for autocomplete. What we want to do is we want to create a backend for our application. So this backend will be in Node.js, and it will be responsible for communicating with MongoDB Atlas. So let's go ahead and open up an editor. In this case, I'm choosing to use Visual Studio Code. Within a new directory on your computer, in my case, I've named it Autocomplete, go ahead and create a new directory within that directory. So I'm going to call it make directory, and I'm going to say backend. Now, you don't have to use the make directory command like I did through the command line. You can create it however you feel the most comfortable. What I'm also going to do is I'm going to make another directory, and I'm going to call this one frontend. So the front end is going to contain all of our user-facing code, and the back end is going to include all of our code, which consists of our API. We're going to start by coding our back end. So what I'm going to do is I'm going to open up and split this terminal, and I'm going to navigate into the back end. Within the back end, I need to initialize a new Node.js project. So I'm going to say npm init-y. What that did was it created a package.json file for us. Now what I want to do is I want to install each of the dependencies that we want to use for our Node.js project. So I'm going to say npm install MongoDB express body parser and course, and I'm going to say save. So we have all of our packages installed. What I want to do now is I want to create a new file. I'm going to call it main.js. If you don't feel comfortable creating that file with the command line, go ahead and create it manually or however you feel the most comfortable. Let's open up that main.js file. And again, this is inside of our backend directory. What we're going to do is we're going to include a few dependencies that we've just downloaded and installed, and we're going to configure our Express framework project because we're going to have an endpoint that is responsible for searching. Let's go ahead and say constant and then Mongo client, and we're going to say equals require MongoDB. Next, we're going to say constant express equals require express. We're going to say constant cores equals require cores. We're going to say constant body parser equals require body parser. And now we're going to actually configure our MongoDB client. So you'll notice that the first 4 lines were just the packages that we installed with npm. So now what we want to do is we want to say constant client equals new Mongo client, and we're going to pass it in our Atlas URI string. So going back into our web browser, let's go ahead and click on Atlas, and let's go ahead and click on connect. What I'm going to do is I'm going to say connect to my application, and I'm going to copy the URL that it's given me. Now, ideally, what you'd probably want to do is you'd probably want to store the URL in a configuration file or within your computer's environment variables for security reasons. But for this particular example, I'm just going to paste it into this particular Mongo client constructor. Now, what we want to do is we want to change a few things. So for example, our database is actually going to be food. Our username, which I've created prior to this tutorial, is called YouTube. And the password is going to be password 1234. Now, this particular user account will have expired by the time that this tutorial finishes, but that's all right. It's going to be valuable when it comes to this particular example. So I'm going to save it. Next thing I want to do is I want to initialize Express. So I'm going to say constant server equals Express, and I want to apply each of the packages towards our Express framework. So for example, I'm going to say server.use body parser .json server.use body parser .url encoded. Extended is true. And then finally server.use cores. With that done, let's go ahead and listen for requests. So I'm going to say server.listen. I'm going to listen on port 3000, which is a typical Node.js prototyping port. And I'm going to say async function. Now within this callback function, this is where we're actually going to connect to MongoDB. So I'm going to say try. I'm going to say await client.connect. And then I'm going to say collection, but actually let's go ahead and define that collection first. So I'm going to say var collection, because we plan to use it in our endpoint function. So I'm going to say collection equals client.db food.collection recipes. If there was any kind of error, I'm going to catch for it. Perfect. So you could have easily added food and recipes to an environment variable as well, but for this example, we're just going to hard code it. Now that we have a connection to MongoDB, what we want to do is we want to create our endpoint functions that will be responsible for our autocomplete search. So let's go ahead and create that function. So I'm going to say server.get. I'm going to say search. And I'm going to say async. I'm going to say request response. And we're going to have our logic in there. Now we will be creating another endpoint function later on, but for now, the whole point of this tutorial is around our autocomplete search. So let's go ahead and see what that looks like. Let's go ahead and say try, and we're going to catch if there was an error. So I'm going to say catch E. And if there was an error, we're just going to say response.status, some kind of 500 error. I'm going to say send. And maybe if there was an error, we're going to say message and then whatever the message was of that error. We're just going to send it back to the client. Otherwise, if there was no error, what we're going to do is we're going to do an aggregation against MongoDB. So we're going to say let result equals await. We're going to say collection.aggregate. And we're going to pass in an aggregation pipeline. So this particular pipeline is only going to have one stage. Now, when it comes to autocomplete or Atlas search in general, you can have numerous stages. You could do some kind of search, and then you could do some kind of further aggregation on that data that comes back. But for our example, we want whatever data comes back, we just want to send it straight to the client. So let's go ahead and create our one stage. So this one stage is going to be search. It's going to use the autocomplete operator. We're going to provide it a query. This query is going to be whatever the user passes in. So I'm using a backtick character so that way we can embed the request variable directly in the string. So I'm going to say request.query, and let's go ahead and say that maybe it is called term. Let's go ahead and add a path. So for this example, because we chose to use dynamic false when it came to creating our index, we want to provide a particular path within our index to actually do our autocomplete search. So we only created an index on the name field. So that's what we're going to be using. What we're also going to do is we're going to use the fuzzy operator. So the fuzzy operator will give us some wiggle room when it comes to the terms that are entered in our search field. So for example, maybe I make a typo in my search. Well, we can specify how many typos in our search are acceptable to still get results, that kind of thing. And you can play around with this value, and it's also in the documentation as well. So let's go ahead and say fuzzy, and I'm going to say max edits. And the max edits in this example is going to be 2 characters. So let's go ahead and save it. So we have our result. What we probably want to do is we probably want to send it back to the client. So we're going to say to array. So this will actually take our result set. Rather than having a cursor, we are taking the entire result set and creating an array out of it. And we're going to say response.send. It'll automatically choose a 200 response of success. And we're going to say result. And I'm going to save it. So this should be a fully functional endpoint. And we can actually test it out. So let's go back into our web browser. And I'm going to create a new tab. And I'm going to say localhost 3000/search. And it's going to fail right now because I'm not actually running the application. So let's go ahead and go back into our terminal. And I'm going to say node main.js. So let's go back into the browser now. You'll notice that we get an empty array back because I did not provide a term. Right now we have an empty query. So let's go ahead and add a query. So let's go ahead and say term equals, let's go ahead and say that we maybe want cheese and see what comes back. So we have two results that came back. So grilled cheese and cheesecake. Let's go ahead and misspell cheese a bit. So let's go ahead and say cheese with an A in there. Well, you know what? It still worked because of our fuzzy search. So this is the type of stuff that we're going to be working with when it comes to our front end form. So let's jump into the front end side of things. What we're going to be using for this example is we're going to be using Jquery Ui, so the autocomplete functionality of Jquery Ui. So basically what happens, Jquery Ui provides us with a framework that will allow us to make an HTTP request against our backend endpoint in order to populate our input form with suggestions. It makes it easy for us. We don't have to use Jquery Ui to get this job done, but it's a very easy way to get the job done. So let's go ahead and go back into our editor. This time around, we're going to be adding files to the front end directory. So what I'm going to do is I'm going to say touch index.html. And this created an index.html file directly in that front end directory. Now, if you're not familiar with the command line, no worries. Go ahead and create that index.html file however you feel the most comfortable. Let's go ahead and open that file and let's start adding some boilerplate HTML. So for example, I'll add the doc type. I'll say HTML. I'll say head. We'll say body. And we can start adding our logic in here. But first, let's go ahead and import Jquery Ui. So we're going to use a CDN to get the job done. So you can download it, you can use a CDN, you could host it yourself. It's totally up to you. But what I'm going to do is I'm going to say, I want the minified version. So I'm going to copy that. I'm going to go back into my code and I am going to import it. So I'm going to say script source equals, paste that in. What we also want is the theme. So let's go ahead and copy the theme that we get out of it. So let's go ahead and say we want maybe the base theme. So let's copy that and go back into our editor. Let's go ahead and say link. The relationship is going to be a style sheet. And we're going to say href equals that URL. Finally, what we want to do is we want to copy jQuery. So let's go back into our browser and let's find the jQuery version that we want to use. So we want jQuery core. So I'm just going to open up a new tab and I am going to copy the minified version of jQuery, the latest version. So I'm going to click minified. It's already providing us with the actual script tag to use. So let's just go ahead and copy that. Go back into our code. And we're going to paste it above the Jquery Ui because the dependency of Jquery Ui is in fact on jQuery. So I'm going to save it. So now that we have that taken care of, what we can do is we can start making our UI component. And there's actually not going to be a whole lot of code involved. So inside of the body, let's go ahead and create our container for the particular search field. So I'm going to say div, I'm going to give it a class, and I'm going to say UI widget. Now within the UI widget, let's go ahead and create a label. The label is going to be for recipe, because that's going to be the name of our input, and we're going to call it recipe. And then we're going to do a new line. Let's go ahead and say input, and we're going to say ID, because the ID is going to be important when we reference it with our jQuery, but we're going to say recipe. And we're going to leave it at that for now. What we want to do outside of this div is we want to create another script. This is where we're going to have all of our front end logic. So for example, we're going to have document, and we're going to make sure that it's ready before we try to use it. So we're going to say function, and we're going to add all of our code within that ready, because at that point in time we know that we're ready to use this jQuery. So to use Jquery Ui and this autocomplete functionality in specific for Jquery Ui, this has nothing to do with MongoDB as of right now. What we're going to say is we're going to say $, recipe, and this is going to be in reference to line 12 where we gave it an ID of recipe. And we're going to say autocomplete, And we're going to provide information as per the Jquery Ui autocomplete functionality. So for example, we have a source. The source is going to be where we get our information from. In this case, it's going to be our MongoDB application. So I'm going to say async, I'm going to say function, and I'm going to say request and response. And what we want to do is we want to do a fetch command. So we want to do a fetch command against this remote API, which as of right now is local on my computer, but it could be a remote API somewhere. Let's go ahead and say let data equals await, and we're going to say fetch, and I'm going to say using a backtick character so that way we can embed our variables. We're going to say HTTP localhost 3000 /search, and we're going to say term equals $request.term. So this is going to be what is actually sent to our backend. This is a promise, so we're going to say .then, and we're going to say results equals results.json, so we're going to convert it into JSON. And then we're going to figure out what we want to do with the actual JSON results. And we actually need to format it so that way it can be properly displayed on the screen. So we're going to say .then, we're going to say results equals results, and we're going to map those results. So we're going to say map, so we're going to say result, and this is going to be the function for our map, so that way we're actually going to return a properly formatted array of data. So let's go ahead and check it out. Inside of our map, what we can do is we can say return, and what do we want to return? Well, we want to return the recipe name, so this is going to be the label. So we're going to say result.name. So this is the result name for any particular item in that array. We want the value because it's going to be affecting what happens when we actually click on that within our autocomplete suggestions. So we want the value, which in this case is also going to be name. So they're going to match. We're going to say result.name, and we'll maybe play around with this as we progress. And then finally, maybe we want the ID. So the ID could be result._ID. So this is the data that we get back. And we actually want to show that we're done with this particular request by saying response data. So we're actually going to be doing a response callback to tell this particular Jquery Ui library that, you know what, we have the data that we need. Now let's go ahead and say in order to use the autocomplete, we need to provide a minimum length of characters because we don't want to necessarily hammer our API with requests. We could, but we're going to choose not to in this example. So we're going to say min length, and we're going to say that there must be 2 characters in order for the request to be made, at least 2. Then what we're going to do is we're going to say select, and we're going to say function, and this is where we're actually have the ability to do something with the results. So do we want to display them on the screen after we select them from our suggestions, or do we want to do something else? For now, let's just go ahead and display them in the browser console logs. So we're going to say event UI. We're going to say console.log, and we're going to say UI.item. And we're going to save. So let's go ahead and see this in action. Now, what you're going to want to do is you're going to want to serve this particular file. You could be using Python to serve this particular file. You could be using an npm package that I like to use called serve. You could use other means. You cannot just open this index.html file from the file system. So in this case, I'm going to say serve. So I do have my backend running. My backend is running on port 3000. My front end is running on port 5000. Let's go ahead and go back into the browser. And I'm going to go and I'm going to say localhost port 5000. And you'll notice that I have a recipe box right here. I'm going to open up my console and I'm going to start typing. So I'm going to say ch, and after 2 characters were added, it now says grilled cheese or cheesecake because those are 2 items that exist in MongoDB. Now, if I wanted to, I can say maybe cookies, nothing. So you get the idea. So let's go ahead and type one in. I'm going to say cheese, and I'm going to click on cheesecake. You'll notice that inside of my console logs, it now printed out the ID, the label, and the value. Now, we don't have the ingredients here. Do we necessarily want an array of ingredients to come back when we click on items from our autocomplete? Well, maybe, maybe not. So in this case, if we click on one, maybe we actually use the ID and issue a second query against our backend, which will get the rest of our data. So let's go back into our code. What we can do is we can go back into the main.js file. So this is part of our backend, and we can actually create another endpoint. So let's see that happen. We're going to say server.get. We're going to say get, and we're going to say that, you know what, we're going to be provided with an ID. So hence the colon and then ID. We're going to say async request response, and let's go ahead and see what happens. So I'm going to say try. If there was an error, I'm going to do the same thing that we saw with the other endpoint. So I'm going to catch it, and I'm going to say response.status 5000.send, and I'm going to say message and then e.message. But you know what? If there was no exception thrown, that means that we're on the right track. And we can say let result equals await collection.find1. Let's go ahead and pass in the ID that we received. And this is going to reference the ID field of the document. So we're doing a find1 with the filter on the ID field. Now we can't just take the request.params.id because we have a hash, and what we really want is an object ID. So if we scroll to the top of our code and we say object ID, now we can actually convert that into an appropriate object ID. So let's go ahead and wrap this. I'm going to say object ID. And now we have a functional query. So with the results, let's go ahead and say response.send, and we're going to say result. Because this is a find one, we don't need to do to array because we're only ever going to get one document back maximum. So this will work out fine. So I'm going to save it. I'm actually going to restart the backend in our terminal. So I'm going to say node main.js. I don't need to restart the front end, but we do need to actually make changes to the front end. So let's go ahead and remove this console.log for the UI item. We actually want to display it now. But before we do that, we need to do our fetch with the data. So we're going to say fetch. We're going to say with a backtick character, HTTP localhost 3000, and we're going to say get, and we're going to provide the ID, which in this case is going to be ui.item.id. If it was successful, we're going to say then, we're going to say result and convert this into JSON. And we're going to do something with the actual JSON result. So we're going to say result, and in this case, we need to display it on the screen, but we don't have anywhere to display it to as of yet. So we actually need to make that happen. So let's scroll up a little bit. Right below our input, and this is just going to be a very basic example, but right above our input, because we don't want to display it in the console, is we can do the following. We can say UL ID equals ingredients, and then close it off UL. And we're doing an unordered list because you know what, our data is already an array. So let's just display it as a list. It makes sense. So we have the ingredients as noted by the ID attribute. So let's go ahead and use some JavaScript to populate it. So I'm going to say ingredients. I'm going to say, first of all, empty our ingredients, because you know what, if we ran this search before, we don't want to double down on the data that exists in that search. So we're going to empty it, and we're going to say result.ingredients.for each. So this is a loop on our resulting ingredients. So this is the ingredients from our MongoDB, and we're going to say ingredient, and we're just going to add them to that unordered list. So let's go ahead and say ingredients dot append, and we're going to append a list item ingredient, and we're going to close that list item. So let's go ahead and see if it worked. Now if you're using serve like I am, you don't need to restart the front end. It'll automatically consume all of the changes that you make. The back end is good, so let's go ahead and try to refresh. So what I'm going to do is I'm going to type in maybe cheese again, because those are the only results that we have. I'm going to click on one, and you'll notice that it shows the ingredients for cheesecake. Now, if I were to say something like cheese, like grilled cheese, because we chose to use empty, it now shows the new ingredients for that particular recipe. And again, we only have 2 documents in our collection right now. To get the full power of this feature of MongoDB, you're going to want a lot of documents. So try it out, play around with it, see what you can do. Let's go ahead and revisit what we have in our code. We created 2 different files within our project. So we had a backend and a front end. The backend being Node.js, we chose to make it an Express framework application. This Express framework application had 2 endpoints, the first being search. So the search endpoint, what it did was it did autocomplete. We did a search based on a particular term and a particular path within our collection. So in this case, name, because that's what our index was on. We also chose to use fuzzy, so that way we can make mistakes. And our other endpoint was if we had the ID, we can just do a basic find one with a very basic filter on ID. So we didn't have to use an aggregation pipeline. Now, like I said at the beginning of this tutorial, this aggregation pipeline, you can use autocomplete as the first stage, and then you could do further manipulations on that data using other operators. So it could get far more extravagant depending on what you're trying to do. So this is just one of many examples that you can use when it comes to the autocomplete operator, or just any functionality that might exist in Atlas Search.